Say you want to have some pixel have half the intensity as some given pixel. Logically, you'd set the pixel's channel values to be half that of the originals. This is certainly a reasonable idea, and in fact I recommend it once you have your system set up properly. The only problem is that displays do not actually respond to channel settings in this way. A monitor has a power law response to an input signal. If you send a signal of say 0.5, you get a result down here. You send a signal of 1, double it, you get way more than double the result. This nonlinear response of monitors sounds like something that should just get fixed, but it's in fact a feature. It turns out that our eyes have a similar response curve. A monitor has a limited number of levels of color it can display. To get good coverage of levels that the eye can detect, it's a fine thing to space these levels out in this nonlinear way. However, we usually think we're calculating colors in a linear space. If I compute a color that's half as intense, I expect to see that result. Many applications ignore this mismatch between how to calculate color and how to display it, and it's less noticeable than you might think. If everything you do is in this space, then you often don't feel anything's wrong. It's what you're used to seeing. In fact, I'll warn you that many of the shader program examples in this unit blithely ignore this problem, since the focus is on keeping the program simple. However, there are a few important places where computing in the monitor space can cause problems. First, lights don't add up correctly. If you have two spotlights overlapping, this area of overlap will not be twice the intensity as the individual spotlit areas. If you want to be more physically based and be able to trust that your virtual world has some connection to the real world, you need to add the lights together sensibly. The hues of colors can shift. As you vary the intensity, the channels shift in a nonlinear fashion and so shift the perceived hue. Anti-aliasing won't look as good. Say you have a white polygon on a black background. If a pixel is half covered by a polygon, it should be half the intensity as the one fully covered by the polygon. If no corrections made for the monitor's nonlinear response, the half-covered pixel will be dimmer. This error will cause even highly sampled pixels to be wrong and give what's called braiding or roping along the edges. I say this a lot, but you really owe it to yourself to see the additional course materials for a comparison. Mipmapped textures will appear dimmer in the distance. The simplest case is the mipmap for a 2x2 checkerboard pattern. The 1x1 average mipmap is a gray level of 0.5, but as I've said maybe 5 times now, this gray will appear darker on the screen. This can cause textures with high contrast to look dimmer as these lower resolution mipmaps are accessed.